Now we're going to step into the DetectMultibackend class. Here we're feeding in the weights YOLOv5l.pt, our device, CPU, DNN set to false, data is set to Coco 128 YAML, and then half is set to false. So here we're inside the DetectMultibackend class. We're performing some imports, particular attempt download and attempt load. Here we are initializing the superclass nn.Module. nn.Module is the base class for all neural network modules within PyTorch, and all models should be subclassed to this one. Here, if our weights were a list, which is not, we'll get the first index on the list. In our case, it's just a value, so W will become the weights. Here, we're determining the model type. Well, in our case, we have a PyTorch model, so this is true, and all the other file formats are set to false. FP16 is set to false, not just here, but on the function that called it. These will become false as well. We're not using any of these model types, so all of these values will become false. Here, we're defining the stride with a value of 32. We're not using the GPU, so CUDA is set to false. In our case, these will not apply to us, so we'll step over this, and then we'll step into this if statement. We'll jump into the attempt load function, which takes the weights, which are YOLOv5l.pt, and then the device CPU in place true and fuse true. We will do some initial imports, in particular the detect and the model. We will create a model that is an ensemble, which is right here. So we'll step into the ensemble class and we will initialize it. Now our model, when we run this, is an empty ensemble. Again, our weights are not a list. We only have one set of weights. We could have multiple, but in this case, we're only using the YOLOv5l. So that will get wrapped into a list, and then we will get the first and only value. Here, we will run the torch.load function that also will have a function inside it, attempt download, and this will be mapped to the CPU.